Good evening, everybody. I wanted to make a couple videos here to help you out with Unit 4, which talks about z-scores and finding the areas associated with z-scores. So the first thing that we're going to talk about today is what is a z-score, and this is a little bit of review from, I believe it's chapter 4, the z-score, and you'll have to bear with me here because I'm not very good with this new tablet, but the z-score, let me go up here. Hold on one second. Okay. The z-score is, from your notes, if you look, z is equal to your x score minus what your mean is, which we'll call mu, divided by the standard deviation. Okay, so that's your formula to calculate z-scores every time. Now, if we look at the problem here, this is from your notes. Bowling Green's October high temperatures are approximately normally distributed with a mean of 71 degrees and a standard deviation of 4. We want to find what this distribution looks like, and then they're going to do some percentages. Now, this problem is actually um, using the empirical rule more than anything, but let's lay out the distribution. So, if we have a mean of 71 and a standard deviation of 4, remember that the mean is always right here in the middle. So, scroll up a little bit here. Your mean goes right here. This is 71. And then we just simply add and subtract the standard deviation of 4. Now, remember that in the normal distribution, this is 0, this is plus 1, this is plus 2, this is plus 3. Those are z-scores as well as standard deviations. This is minus 1, this is minus 2, this is minus 3. So 71 goes in the middle where 0 is. That's your mean. And then we're going to add 4 3 times, and we're going to subtract 4 3 times. So your first standard deviation here is going to be 75. That's plus 1 z-score. The next one here will be 79, which is plus 2 z-score. And the next one will be 83. That's adding 4 3 times. So if we were to somewhere to ask you, what is the z-score when the mean is 71 and the standard deviation is 4, you would say z is equal to, if you were trying to find what 83 was, this would be 83 minus 71 divided by the standard deviation of 4. Okay? So, let's see. This is going to be 8. No, excuse me. What is that? 12 over 4, which would simplify to 3. So 83 has a z-score of 3, and there's your 83, and as we see, it has a z-score of 3. Okay. Now let's go in the negative direction. This is 71, so we're going to go minus 4, okay, which would give us 67. Minus 4 again would give us 63, and minus 4 again would give you 59. Okay, so we have our distribution laid out. Now, these are only on the whole numbers. Okay, one of the things that the z-score is going to do for you is it's going to allow you to find things like z is equal to 2.5. Okay, so places in between. All right, but that's the basic idea of what a z-score is. It just simply tells us the number of standard deviations that a score falls either above the mean or below the mean. So like I said, 83 here is 3 standard deviations above the mean. It has a z-score of 3. 63 is negative 2 standard deviations below the mean. If you want to confirm 63, we'll do it right here. Z is equal to 63 minus your 71, which is your mean, divided by 4. Okay. So this is going to give me negative 8 over 4, which is equal to negative 2. That's negative 2 standard deviations below the mean, and there it is. Okay. Hope this helps. In the next video, we're going to talk about finding areas associated with z-scores.